Hello students, now we will be moving on to deriving the various forms of equation of a line in space. So a line in space can be uniquely determined, or you can draw a line in space with two information, means the point through which it has to pass and in which direction it has to be drawn, or the point through which it has to pass. You need 2 points to draw a line in space. So with these information, either you need 2 points or 1 point and the direction of the line. So with this information, you can determine a line, or you can draw a line, or you can construct a equation of a line. So let's construct, or let's derive the equation of a line in these situations. So very first form is this: equation of a line through a given point ax1 y1 z1 and parallel to a given vector this. So you are given the information of the line. You have to construct the equation of a line such that it has to pass through one point and it has to parallel to this vector. So you are given the direction of the line and you are given the point on the line. So with this information, you have to construct the equation of the line in vector as well as in Cartesian form. So these are the forms you have to derive. So remember, we will be proving these. So let's understand the proof. So consider the coordinate axis x, y, z axis, and we are supposed to construct a line which passes through a point. So let us A be the point x1, y1, z1 in this space, and the vector B means you want the line in this direction. You are given the direction of the required line. So let us assume that this is vector B, ai cap, bj cap, ck cap. Now we have to construct or draw the line which passes through this. So we want this line. This is the required line which passes through the point ax1 y1 z1 and parallel to this vector. So this is the figure you have to remember. Now in order to derive equation of any line, we need one general point. So take any general point on this line L. So let us Pxyz be any point on this line. You can take anywhere here on the line L. Now you have to find one condition which can be satisfied by this point. So that will be the required line. Now draw position vectors for A and P. So let vector A be the position vector of the point A and vector R be the position vector of the point P. Now apply the triangle law. So this is the explanation for this figure. So better you note down by pausing the video. Okay, so let's understand the proof. So P is the any point and R is the position vector as I explained earlier. So now let's see here what will happen. So in the figure, vector AP is parallel to what? It is parallel to B, because you have constructed in such a way, because you require this line such that it is parallel to vector B. So we have taken the line L is parallel to vector B. So clearly vector AP is parallel to vector B. That means, as I said earlier, if these two are parallel, then they are collinear vectors. So AP is parallel to vector B, so they are collinear. So you can express AP in terms of vector B. So vector AP can be expressed as lambda times vector B. So where lambda is any real number. Okay. Now AP can be expressed in terms of position vector. How will you write AP? AP can be written as OP minus OA, as I mentioned earlier, and this is lambda B vector as it is. OP is what? It is vector R and OA means vector A. So substitute there. So it is vector R minus A is equal to lambda B. and transfer this minus a to the right, you will get vector a plus lambda b. So this is the vector equation or vector form of the equation of the line. So remember this proof, very simple, only using this knowledge, collinearity of two vectors. Let's understand the Cartesian form. So now to derive the Cartesian equation, we have already what we have taken this as a and this as r and this as b, and how a can be written as position vector can be written as in terms of component form that we studied in vector. So if x1 y1 z1 are the coordinates, then its component form is x1 i cap, y1 j cap, z1 k cap. Similarly, vector r is, you can write xi cap, yj cap, zk cap. So substituting these values in the previously derived vector form. So put these values or these forms in this equation. So what will get? See here. This is your equation. Substitute R, A, B. So if you substitute R as this, okay, you'll get this. Now you can from these two terms take I cap common. If you take I cap common, x1 plus lambda A, from these two terms j cap common, y1 plus lambda b. Similarly for k cap also you will get z1 plus lambda c. Now you can equate the coefficients of I, j, k, because this vector is equal to this vector means definitely their corresponding coefficients are equal. So equate the coefficients of I, j, k. So what is the coefficient of I here? X, and here coefficient of I is this. So let's equate x is equal to x1 plus lambda a and simplify in this way. X minus x1 is equal to lambda a. So a bring down, so x minus x1 is equal to lambda. Similarly, equate the coefficients of j cap. So what will you get? This. And one more last thing, that is equate the coefficient of k cap. So you will get this. These are nothing but these are called parametric equations of the line. We want Cartesian form, so eliminate lambda. So this is equal to lambda and this is equal to lambda and this is equal to lambda. So eliminating lambda means this is equal to this is equal to this. So you can write x minus x1 by a is equal to y minus y1 by b is equal to z minus z by c. So this equation is the Cartesian form of the equation of a line passing through a point and parallel to a given vector. So remember this and this, these two equations has to be remembered. This is the vector form and this is the Cartesian form. Okay. Now one thing to be noted, if Lmn are the direction cosines of the line, then the equation of the line also can be written as this. Okay, instead of a, b, c, you can write Lmn, because Lmn are also be the one set of direction ratios, because L by L, M by M, N by N is equal to 1. So direction cosines are proportional to themselves. So direction cosine can also be treated as one set of direction ratios. So if you have direction cosines with you and a point with you, you can construct the line. Okay. So this thing to be noted. Okay, now we have an example on this, whatever you studied. Find the vector and Cartesian equation of the line that passes through the point 1, 2, 3 and parallel to the vector 3i cap, 2j cap minus 2k cap. So you are given one point and the direction of the required line. So let us A is equal to 1, 2, 3 and we call as x1, y1, z1, and its position vector is given by vector A is equal to A vector, that is 1i cap, 2j cap, 3k cap. Okay, from the point you can write its position vector, and you are given the required line is to parallel to which vector. So this is your vector B. Okay, so take it as a vector B, and which is generally written as ai cap, bj cap, c k cap. So vector equation is given by what? That we studied earlier. Vector r is equal to vector a plus lambda b. So substitute this vector and vector b is this. So this is the vector equation of the required line. Now we will have Cartesian form. The equation of a line in Cartesian form is given by x minus x1 by a, y minus y1 by b, and z minus z1 by c. So x1, y1, z1 are these points. So substitute here, and a, b, c are the coefficients of I, j, k in the vector b. Okay. So substitute the coefficients of a, b, c, I, j, k in this. So this is the Cartesian equation or Cartesian form of the given required line. Okay. Now see here, if you are given this form, immediately you could able to tell that what are its direction ratios and what is a point on the line. Suppose if anybody gives you this equation, so these points, if you have minus 1, minus here, and 1, 2, 3 stands for, it is a point on the line, and the denominators 3, 2, minus 2 stands for they are the direction ratios. So from this line you could able to tell a point on the line and the direction ratios of the line. So remember this thing. Okay, you have one more example. Find the vector and Cartesian equation of the line that passes through the point and parallel to this vector. Okay, so simple, this is your point x1, y1, z1, and this is the vector b. So directly vector a plus lambda vector a plus lambda vector b. So this is your vector a. Okay, try this as I did earlier. Okay, so this is for your practice. So do it in detail. This is your Cartesian form and this is your vector form. So please practice this or take down. Now see here, the Cartesian equation of the line is this. This is your given Cartesian equation. Write its vector form. So as I said earlier, looking at this, you are given one line here. Then you could able to immediately tell what is the point on the line or the point through which it passes. So if you write it in the standard form, like in the form of x minus x1, y minus y1, z minus z1 by a, b, c. So this y plus 4 can be written as y minus of minus 4 and rest of the thing as it is. Okay, now it has in the standard form x minus x1 by a, y minus y1 by b, z minus z1 by c. So what are x1, y1, z1? So this is your x1, this is your y1, this is your z1. So comparing this with this equation, standard equation, you will get a, b, c as this. So we get x1, y1, z1 as 5 minus 4, 6 and a, b, c as 3, 7, 2. Okay, so these are the x1, y1, z1 and a, b, c. Now we can write the vector, position vector a as this 5 i cap minus 4 j cap plus 6 a cap, and vector b using these are the direction ratios 3 I cap plus 7 j cap plus 2 k cap. So now you can write the vector form as this. Vector r is equal to vector a plus lambda vector b, and substitute vector a and vector b. So in this way you can write a vector form from given Cartesian form, and conversely also you can write from given vector form you can construct Cartesian form. So let's, here is one more example for your understanding. Find the Cartesian equation of the line that passes through the point this and parallel to the given line. You are given this line, means your line has to parallel to this line and it has to pass to this point. Okay, so let's see here. So this is your given line. Can you tell me the what are the direction ratios of this line? Direction ratios of this line are 3, 5, 7. Okay, now we want a line which has to this line has to parallel to this. Okay, means what are direction ratios of this? They are same as that of this. So 3, 5, 7 are also the direction ratios of this line. So A, B, C are your 3Bs, 3, 5, 7. Okay, so from the given information, okay, you are supposed to construct a line which passes through this point. So take this as x1, y1, z1. And what is if you write this in the vector form, okay, this, if you write this line in the vector form, what is vector b? You will get, what are the direction ratios of this? 3, 5, 7. So this vector can be written as in the vector form 3i cap, 5j cap, 7k cap. So this is the vector b. Now we want a line which is passing through this point and parallel to vector b. Okay, so very easily you can write this. Equation of the required line is this. Looking at this, x minus x1 by a, y minus y1 by b, z minus z1 by c. So here x1, y1, z1 are this. So minus of minus 2 becomes plus 2, minus 4, and z minus minus 5 means z plus 5 divided by 3, 5, 7. So this is the required Cartesian equation.